Does this function intimidate you if you're asked to graph it? In this step-by-step math tutorial, I'm going to show you how to not just graph this step-by-step with easy to understand intuitive explanations, but also how to graph any other function like this. We're not going to use calculus, but we're going to introduce some ideas with limits. Don't worry if you don't know them, it's all going to be explained in this video, and we're going to master graphing this function. So the first step when graphing any function is always to look at the domain of the function. So step one is find the domain. Now in math, when you're trying to find the domain of a function, you just want to make sure you're not dividing by 0, taking the square root of a negative number, etc. Something illegal. So here you want to make sure you're not dividing by 0. So when is the denominator 0? Okay, so let's head over to the right side of the board to figure that out. So what is the domain going to be? Well, we want the denominator to be non-zero, so we set the denominator equals to 0. 2x minus 4 is equal to 0. Well, that's the same as saying that 2x is 4, and that's the same as saying that x is equal to 2 if you divide by 2 on both sides. So 2 is the point that will correspond to dividing by 0, and you want to exclude 2 from the domain. Okay, so the domain is going to be everything except 2, and we can write this in interval notation. Okay, so interval notation is minus infinity to union to infinity. All this means is all numbers on the number line except 2, all numbers to the left of 2 and all numbers to the right of 2 combined, but you're not including 2 because you have a parenthesis here. So that is the domain of the function. That's step 1. Now step 2 is find the intercepts of the function. Okay, so it's always good to do it in the easier steps first, so then if you're doing it on a homework or assignment or an exam, you can get partial credit and get a strong foundation on your problem. So the next step is to find x-intercepts and y-intercepts. Okay, so x-intercepts plus y-intercepts. And how are we going to find x-intercepts plus y-intercepts? So the way we do this is follows. Again, I'm going to give you the magic formula, always the simple steps to follow that you can apply to any problem. So for the y-intercepts, which I find are always easier, so we take the y-intercept first, that is when the graph cuts the y-axis. But if you think about the xy plane, it cuts the y-axis when x is 0. Okay, so we have to just set x equals to 0 and find out what y is. So if x is equal to 0, then y is going to be equal to minus 3, 0 minus 3, so it's going to be minus 3 divided by minus 4, which is going to equal to minus 3 over minus 4 is just equal to 3/4. Okay, so it's going to be 3/4. So that is the y-intercept. For the x-intercept, it's on the x-axis, so the y-coordinate is 0. You're not going above or below the x-axis. So for the x-intercept, you're going to set y is equal to 0. So here, x-intercept, you set y is equal to 0. Now that's going to be solving the equation. The formula for the function is equal to 0. What is x going to be? So x minus 3 by 2x minus 4 is equal to 0. Cool thing with equations like this, if a fraction is 0, it just means the numerator is 0. So you can completely ignore the denominator. So that's the same as saying that x minus 3 is 0, or it's the same as saying that x is equal to 3. Okay, so we know that the y-intercept is at 3/4 and the x-intercept is at 3. Okay, so x-intercept is at going to be at x equals to 3, and the y-intercept is going to be at y equals to 3/4. Okay, so fill in the information we have, and now let's head on to the final 2 steps, which are going to be the trickier steps, and they're going to involve limits. Understanding what this function does at infinity and minus infinity. Okay, so I'm going to walk you through the process here, and you don't really need to have a strong feel for limits. I'll show you what's going on. Okay, so I'll explain this intuitively and also rigorously. Okay, so what we want to do is, we know the domain, we know the x and y intercepts, we want to start connecting the dots. Okay, so we know what happens when x goes to infinity and minus infinity, we can do that. So what we're looking at is we take this expression, this is limit x goes to infinity of x minus 3 divided by 2x minus 4. What this means is what value does the function approach as x gets larger and larger? Here's the intuitive way to look at it. As x gets larger and larger, if x is 10, it's 10 minus 3 over 20 minus 4. When x is million, it becomes a million minus 3 by 2 million minus 4. Now, a million minus 3 by 2 million minus 4 is roughly a million over 2 million, right? Because the negative 3 and the negative 4 don't add anything substantial to the numerator denominator to change the fact the ratio is about a half. So really, when you find such limits, you can just say that you look at the coefficients of x. So here the coefficient is 1, here it's 2. It's going to become roughly x over 2x as x goes to infinity. So the limit is going to be 1/2. Okay, so this limit is going to equal to 1/2. Now, if you want to know rigorously, if you're familiar with limits, you can quickly skip over this part if you want and proceed to the next one, but I'm just going to quickly show you the rigorous explanation. So the way we think about this is an infinity over infinity indeterminate form. So the top is going to infinity, the bottom is going to infinity. Like with 0 over 0 indeterminate forms, when it's 0 over 0, you cancel something from the top and bottom to then kind of figure out what the limit is. We can factor something from the top and bottom. Here's a cool way of factoring. Factor the x out, because the x is what is going to infinity on the top and bottom. That's creating the infinity by infinity behavior. Factor the x out and you get x times 1 minus 3 over x. And on the bottom, you get x times 2 minus 4 over x. So all I've done is I've divided the top and bottom by x basically. Okay, so I get 1 minus 3 over x and 2 minus 4 over x. And now you can cancel the x's and you're just going to get limit x goes to infinity of 1 minus 3 over x divided by 2 minus 4 over x. And now we're precise about the idea that the 3 and 4 become negligible, because as x goes to infinity, the 3 over x, 3 over a big number is 0, going to 0, and the 4 over a big number is going to 0. Okay, so here we're going to get 1/2, and this is an important thing to understand rigorously, and actually it's the same even if x was going to minus infinity. If you do all the same steps, you will see the answer is the same. It does not matter. If x goes to minus infinity, it's the same answer. So this is also equal to the limit as x goes to minus infinity of our function x minus 3 by 2x minus 4. Okay, so that's going to be half. And what this means is that our graph of our function, the y values will approach half at negative infinity and positive infinity. Okay, so we can write that here, fill in our information here. The limit as x goes to infinity is equal to 1/2 is equal to the limit as x goes to minus infinity. Now, I'm being a bit imprecise here because I haven't written down the function. Of course, just saying limit doesn't make sense, but I'm just kind of doing it because you understand, we're just taking notes. And now the fourth step is we need to figure out what we're going to do to find out the vertical asymptote. Okay, so what's happening when the point that's not in the domain, which is when x is 2, what is happening near 2? And once we figure that out, we can conclude everything and graph this function. And I will show you exactly how we think about connecting the dots. It's a beautiful connecting the dots process, and I encourage you to try it out with other functions just by changing up the numbers. Okay, but let's do that now. So what happens near x as x approaches 2? Okay, so we have our function x minus 3 by x minus 4, 2x minus 4, and we want to figure out the limit as x approaches 2 of this. So what does this function value approach as x approaches 2? So when x approaches 2, what's going to happen to the numerator and denominator? That's what you want to think about to get an understanding of what's going to happen to the ratio. So the numerator is going to approach -1 as x approaches 2 because it's going to be 2 minus 3. And the denominator as x approaches 2, well, that's going to approach 0. And when you have something like this where you're dividing by 0, the answer is going to be plus or minus infinity. But it's crucial to understand which one it is, in which case. Why is it plus or minus infinity? Because you're dividing by 0, getting a number really, really small, the ratio is going to become really large, but it could have a negative sign. So it could go to minus infinity or it could go to plus infinity. Now, in terms of understanding which one it does, we have to split up into right hand and left hand limits, and you'll see why. So with the right hand limit, so let's do the left hand limit first maybe. The limit as x approaches 2 from the left of x minus 3 divided by 2x minus 4, what's going on here is that when x is approaching 2 from the left, that means on the number line you have 2, you're basically x is going to be less than 2, but it's going to be close than 2. Close to 2 but less than 2. Okay, so if x is less than 2, well, it's the same idea. I mean, x minus 3 is going to approach -1, the 2x minus 4 is going to approach 0, but if x is less than 2, 2x minus 4 is going to be negative, right? Because if x is before 2, you multiply by 2 to x, you'll get something less than 4. So 2x minus 4 is negative. That's the crucial information. So what I like to do is I like to put a 0 minus to say that it is a small number, it's going to 0, so we know the answer is plus or minus infinity, but it is a negative number. And so when you have a -1 over a negative number, it's going to become a positive number, so the limit is going to equal to positive infinity. Okay, so that is the left-hand limit, and it matters because when you take the other side, when you take the right-hand limit, instead your x is going to be on the other side of 2, your whole situation is going to change. It's still going to be a plus or minus infinity, but sign is going to change. Because here what you can do is you can say the limit as x approaches 2 from the right. Let's just walk through to make sure we really understand. X minus 3 by 2x minus 4. If x is approaching 2 from the right, that means x is greater than 2. That means that 2x is greater than 4, so 2x minus 4 is greater than 0. So again, we can sort of label this, and I encourage you to sort of, practice with this on your own as well. We can say the x minus 3 goes to minus 1, it's always the same, but the bottom, that's what we care about. What is its sign? It is going to 0, but it's going to 0 as a positive number. So if you take the ratio, a negative number over a positive number, but the denominator is going to 0, it's going to be negative infinity. So now that we know that the left-hand limit is positive infinity and the right-hand limit is negative infinity, let's pencil that into our kind of graph, or our steps here. So x is approaching 2 from the left is going to equal to positive infinity, and limit x approaches 2 from the right is going to equal to negative infinity. Okay, so now we can actually graph everything, and this is the final part. It's the most fun part. We've done all the hard work, we can graph it. Now, we haven't used any calculus here except limits. We haven't used differentiation. When you learn differentiation, if you've not learned it yet, if you've already learned it, then you'll know what I've talked about when you get to it. But you can talk about things like concavity, max min, when the function's going up, when the graph is going down. You can be very precise about that. Here we're going to do it a bit imprecisely, okay? So, but it's still going to be correct. So what we're going to do is we're going to plot, first of all, I like to plot the x and y intercepts. Okay, so the x-intercept is when x is 3. So you can sort of write out when x is 3, you get an x-intercept. So I'll put that here. Let's say this is 3. The y-intercept is going to be at 3/4. Okay, so 3/4. So we can maybe even I can draw the scale a little bit better so that we can sort of see this very clearly. Sometimes playing around with these scales takes a little bit of time, so don't worry about that. Just want to kind of make sure you can fit everything into the page. So here you have 3/4. Now, what we want to do is we know the graph is going to go through these points, okay? These 3/4 points and this point 3 on the x-axis. Now, the next thing we know is that at x is equal to 2, it's not in the domain. That was our step 1 that we figured out. And we know the limits are going to be plus or minus infinity. So what I like to do is just to kind of draw a line at x equals 2. You can draw a vertical dashed line. This is what is called a vertical asymptote. Okay, so I write this as VA, vertical asymptote. This is the line x is equal to 2. And what happens here is we know the graph is going to go off to plus infinity or minus infinity. So we know that as x approaches 2 from the left, it's going to be plus infinity, and x approaches 2 from the right, it's going to be minus infinity. Okay, so from the left, it's plus infinity, so we can kind of draw something like this. And from the right, it's minus infinity, so we can kind of draw something like this. Okay, so I've sort of just drawing a small piece of the graph so I can connect the dots, okay, at the end. Now, the next thing is what happens as x approaches infinity and minus infinity. Okay, you could do this in either order. We're just trying to get enough pieces and then join everything up. So as x approaches infinity, it's going to go to half. Okay, so what we now need to do is we need to take this line. This is going to be the line y is equal to a half. And this is what we call a horizontal asymptote. Okay, so this is going to be a HA, a horizontal asymptote. It means that the graph of the function is going to approach the line since the y value is approaching half at both minus infinity and plus infinity. Now, we sort of know that it's approaching half. We know it's going through the point 3/4, so we can kind of do this. And here we can sort of know, we know it's cutting this line 3, and we can kind of go like that. Okay, now we can keep going. We can sort of draw, we can extend. We know it's approaching half, so you can kind of let it closer and closer to half as x goes to minus infinity. And here it's going to be closer and closer to half as x goes to plus infinity. So that is going to be the graph of our function all done. Notice that it never actually hits half, okay? It never hits half. Now, this is actually an important point to mention, is that we've connected the dots. How do you know the graph doesn't do some zigzags or some weird stuff in between? That really comes from calculus. So you can justify that with calculus, or you can also justify that algebraically if you like. You just need to show the function is increasing. So that also is not too difficult. That's a challenge for you. You have to show the function is increasing. If you know how to do that, drop a comment down below if you know how to do that and how you think you'd go about it. It's increasing on this interval and on this interval, so you know the graph has to look like this. It's never going to hit 2, because if you try to say that it's it's never going to hit half, sorry, because if you try to say it's equal to a half, you're not going to be able to solve the equation. Try it out and see. Drop a comment down below as to why. If you say y is equal to half, there's not going to be any x value that's going to work. Okay, so I hope you loved that video on graphing the function x minus 3 by 2x minus 4. And this actually helps you to graph any function of the form ax plus b by cx plus d. Play around with it, try to practice it, follow the same steps. This algorithm I've given you works for any function, and drop me a comment down below how that goes for you. Check out my channel for lots of content on graphing. I love graphing. I've got math at all levels on my channel. And before you click away, I just wanted to say my mission, my vision is to create elite free accessible math education worldwide at all levels of math to help as many people as possible, and to create a library of math. So if you're learning this stuff, you can keep going in your math education. There will be videos for you. So by subscribing, you're always going to be notified of new math content, and it's going to be really powerful and help elevate you to higher levels of math, because you're constantly going to see fun math, cool math, different levels of math, and different math topics. And so I'm so grateful to you for watching and supporting my channel, and I hope I was able to support you with this video. It means a lot to me to record this video. I had a lot of fun with it. I wish you all the best, and I'll see you in the next video.